We'd like to start the next session, which is a panel session. Let me first introduce the moderator. This is Dr. Raymond Huhnke. Dr. Huhnke received his Bachelor's of Science degree at Purdue University, then a Master's in Agricultural Engineering at the University of Illinois, followed by a doctoral degree in Ag Engineering at Iowa State University. Dr. Huhnke is a professor of biosystems and agricultural engineering here at Oklahoma State University and is also the director of the Bio-Based Products and Energy Center and is a co-PI on this NSF EPSCoR RII award. So Dr. Huhnke will act as the moderator for this panel session. Ray?
Thank you, Jim. As you can see, we have our three speakers who with us this morning. They've already been introduced, but I did want to introduce a replacement for an individual who had to cancel at the last minute, and I imposed on my good friend, Dr. Larry Walker from Cornell University. Dr. Walker is professor in biological and environmental engineering, College of Agriculture and Life Science at Cornell. During his 30-plus years at Cornell, he has been involved in a number of biomass to energy and chemical projects, including the assessment of New York State biomass resources available for ethanol production, farm-scale methane production, cogeneration, and application of nanotechnology and characterizing and studying the important biocatalysts for industrial biotechnology. Dr. Walker is director of the Northeast Sun Grant Institute of Excellence and a member of the American Council on Renewable Energy, or ACOR, Higher Education Committee, Steering Committee. And as he says, probably most importantly, he's director of the Cornell's Biofuels Research Laboratory. Dr. Walker's awards are numerous. Those include 2006 New York Science, Technology, and Academic Research Faculty Development Program Award for Industrial Biotechnology Research, Michigan State University Biological and Agricultural Engineering Distinguished Alumni Award, Black Enterprise Magazine Master of Innovation Award, and he has been recently elected as Fellow of the American Institute of Medical and Biological Engineering. So again, I've imposed on Larry to join the panel today to talk about sustainability. My first thought was, how do I start this? And as many cases, many of my colleagues know, I say, so what? What difference is it? Well, just recently, newspaper, the Daily Oklahoman, had an article about gasoline prices. And I'd take a look because it does have some historical numbers in here. In 2007, in which when we started looking at this particular EPSCoR project, gasoline prices started to creep up. Tremendous interest. And in fact, reached a high of about $3.80 per gallon nationwide. At the first day that we were awarded the EPSCoR RII for Oklahoma. At that time, it started dropping. So obviously, somebody knew that we were going to make a big difference in terms of what the gasoline prices would be in the state and the nation. And in fact, it reached a low in January of '09 of about $1.70. But from that point on, it's crept up again. Now, I remember early on when I started talking about this particular research project, there was tremendous interest. People were saying, how can you reduce the price of gasoline? Call after call after call. For the last 3 or 4 months, I have not received one call. But as of today, we're back up to $3.80 a gallon. A big difference. Again, so what? Did find that one of the issues that former Governor Henry Bellman, who was responsible in part for me being part of this particular research activity, in terms of federal deficit, where are we at? Well, I looked at petroleum for January of 2012. petroleum accounted for approximately $30 billion in that 1 month of foreign deficit. The total foreign deficit for that month was about $52 or $52.5 billion. If you take petroleum compared to total, it accounts for nearly 60% of our foreign deficit. And lastly, we think we have a lot of energy available in Oklahoma, gas, petroleum, but I suggest that's still a finite source. Anybody who will listen, I tell them that I'm working for my grandchildren's grandchildren. I'm going to have plenty of energy while I'm still on this earth, but I'm still worried about my grandchildren's grandchildren. Why not take advantage of what resources that we have above the ground rather than below the ground? So with that, we asked the panel, and we've not prompted them in any way on how to address sustainability, but I would ask Dr. Chad Haynes to give his thoughts on sustainability and maybe the direction that we're looking nationally. Dr. Haynes?
Yeah, thanks. I think those are great observations, and definitely sort of helps us consider what we're doing and why we're doing it, and what the time scale is for why we're doing it. The transition from various forms of energy, from biomass way back in the day, to coal, to oil, to natural gas, they take long periods of time, and so I think that taking that long-term view is important, and we should continue to articulate that to the folks that we're all working with and our representatives. So with that said, sustainability obviously of critical importance, right? So global population projections put us at 9 to 10 billion within the next few decades. There's going to be upward pressure on the price of global commodities for food, which will of course increase demand for agricultural land for the production of food. Technologies that would, number one, diversify the feedstocks available for the production of biofuels, I think is going to be very important. So that's part of the thinking behind exploring things like giant kelp, macroalgae, for example. There's a lot of uncertainty around that type of technology, both from an economic standpoint and frankly a regulatory standpoint. That farm that I mentioned that's going to be deployed off the coast of Maine was originally supposed to be deployed off the coast of Santa Barbara, California, but the eelgrass replacement alone was going to cost more than the overall budget of the program, and so that farm was moved to Maine, which actually historically has had a very active kelp farming industry. So we don't know how those technologies will scale, but if you don't ask the question, you'll never get any answers, right? So diversifying feedstocks, whether it's macroalgae, diversifying feedstocks, whether it's hydrogen or direct current or other sources of energy for bacteria to produce fuels is also going to be important. Obviously, maintenance of soil carbon and decreasing the use of nitrogen fertilizer, which is what the Ceres project is trying to do, is going to be important as well. So that's sort of in a nutshell what I think is important.
Great. Thanks for the intro. Dr. Langholtz.
In short, I would agree with everything that's been said so far, and Ray, I really appreciate you taking it to the next generation, and I think people lose sight of that sometimes, and how important that is. I would add that at Oak Ridge National Lab, we have the Center for Bioenergy Sustainability, and there are about 20 of us there contributing to that center and focusing on different aspects of sustainability of bioenergy, like Chad mentioned, and obviously that's critically important. Maybe I'll throw something out there that might be a little bit controversial, but sometimes I can't help but wonder, I mean, I'm very passionate about sustainability. I really am. And we need, obviously, we need to critically analyze the sustainability of biofuels and potential for biofuels. Sometimes I want to say the bar might be pretty high for biofuels compared to conventional crops. Are conventional crops held to the same standards of sustainability? Not to mention our conventional fuels that are entirely unsustainable. So sometimes I wonder if we lose sight of how potentially sustainable the basket of renewable energies can be, including biofuels, and how unsustainable potentially all the other systems are that we depend on as a society day to day. So sometimes I think we shouldn't lose sight of that, keep that in perspective. Maybe that's all I would offer for now, but I applaud the collective efforts and interest here.
Well, we probably take a little bit different view on sustainability. I mean, if I take my personal view, I agree with a lot of what Matt said. From a commercial point of view, sustainability for us means being able to have a pretty consistent feedstock supply year-round, and to make a plant of even 1,000 to 2,000 barrels a day sustainable, we're looking at probably needing between 10 and 20 years worth of a feedstock offtake agreement at known prices. May not be the same price for that 20 years, but we start at a point that we work our way up with the inflation that's there. So sustainability for us is really how can you find a location in the biomass that you can bring in repeatedly, year-round, year in, year out, that amount of feedstock to keep a plant running. The smallest commercial plant we're looking at is about 1,000 dry tons per day of woody biomass. The one commercial project we're pursuing right now is, unfortunately, in Ontario, Canada, because they have such a wood basket that has been underutilized because of the declined pulp, paper, and lumbering industry, that we were awarded a very large wood basket here last year. And it is in a sustainable forest, it's a federal forest, and that's our best chance right now of being able to be located where we can produce the fuel on an extended basis and have the feedstock available. So that's what kind of sustainability means from a commercial perspective.
That's what we need to know as well. Dr. Walker.
Thank you. Sustainability is a bit nuanced for me. We can talk about environmental quality as being part of sustainability. To me, sustainability is very much about sustainable human development. You take the human out of the picture, you don't have development, and from my perspective, you don't have sustainability issues. Now, why is that important? Well, to be honest with you, it's about population. We've got a lot of people on this planet. Human beings represent a big footprint on this planet in terms of resource utilization. If there wasn't so many of us, I don't think we would have this discussion about sustainability. So the bottom line is, how do we sustain human development with the resources that we have? That to me is the bottom line. It's going to be challenging in this century because it's not only energy, it's water, it's food, it's quality of life issues, it's economic development. In this country, we value work. And if you don't provide work for people, how can they sustain their families? So there's a lot wrapped into this definition of sustainability if you bring people into it. I'm of the opinion that we've got major challenges. And for us to address those challenges, we're going to have to be pretty damn innovative over the next 20 to 50 years. And innovation is about bringing good science to the table. And a number of my colleagues here in the room are doing really good science work. But it's not enough just to do good science. Technology is not just science. Technology is about science. It's about science to solve a need, to solve a problem. And when you start talking about solving problems, you get up into the policy domain. And this is one of the areas where biofuels is taking a real licking, is on environmental policy, where it's not seen as green. Okay. Economic domain, it's got to fly economically for it to work. And it has to interface nicely with the ecosystem. And that's a tall order for us to address. And to address that in a timely fashion, that's the other part of the equation. The situation with energy, water, food, that landscape is shifting so dramatically that we've got the added process of how do we innovate in a very short period of time. And then we need to also think about what kind of environment do we need to drive that type of innovation. If you think about it, we no longer have the big laboratories like we used to do, the Bell Labs, for example. We do have the national labs who are playing a major role in the bioenergy area. But the innovation space that we operate in today is much more open, much more fluid, much more dynamic. So how do we operate with policy, with markets, with science to drive that innovation space to address the problems that we have to? And so it's a very, very complex problem, but at the root of it, it is about human development, good or bad.
Great. Thank you. I appreciate opening comments from the panelists. What we thought we'd do now is ask you, the audience, what questions you may have the panelists or any observations that you may have. I'd ask if you do have a question or comment, please state your name, affiliation, and we'll go from there. We got someone with a microphone. Who's going to be first? Oh, all right, Kerry, thanks.
Kerry Dooley, Louisiana State. What Mary said about driving the innovation process, it's pretty obvious that a lot of the innovation in the United States, at least, in the biofuels area and some of the other renewable fuels area, is going to come from small companies. And the big companies have ways of partnering with academic institutions and research groups and things like that that are well established and they're used to it. I think the smaller companies, that's not as developed the landscape. And what I would ask the panel is, can they think of some new ways in which small companies might access some of the academic resources, and the academic groups might also be able to access some ideas from the small companies. I'll give an example. You know, when Phil said about his catalyst, he was taking his catalyst, the wax catalyst, and then it was going to a waste product. Well, some catalytic scientists in the United States ought to be able to figure out a way to recycle that catalyst using the wax that's on it as an energy source for the recycling process. So how are we going to promote that kind of marriage in the United States? Because I don't see a whole lot of that going on right now between these small companies and the academic groups.
Most of what we have going on in working with that are through some of the grants. Probably more related right now to USDA grants, where they put a university that's sort of at the lead, and then we come in as collaborators to develop, and it gives us a forum to exchange some of these ideas. But they're few and far between, and you spend a lot of time, as all of you in the academic world know, trying to prepare for those grants, and only a few of them really come through. So it's not what I would consider the most productive source of interaction between the university, the academic, and the small private industry.
Yeah, I can add a few things on that. ARPA-E really values and has seen tremendous benefit in forming teams with both between academics and small business. The guys that are typically in the small business sphere are better at project management. They're a little bit I'd say, more focused, and they're able to stay more focused because they're able to hire who they need to when they need to, as opposed to in academia, maybe the lag time of trying to get your postdoc on board or finding the graduate students that you need to staff a project. So there's tremendous synergy there, and ARPA-E projects, I think, sort of are a great reflection of that, and we'd like to encourage more of that. The SBIR system in the DOE, so the Small Business Innovative Research Grants, some of you may have had that type of funding. Typically, the dollar amounts are pretty low, and so they're maybe for a few $100,000 a year for phase one, maybe up to $400,000 or $500,000 a year for phase two. One of the things that we've done at ARPA-E is sort of reevaluate how we might want to run an SBIR. So by providing more funds initially to start up some of these efforts, right, so that you can have the right resources in place in order to develop these technologies. I'm not sure if there's been a real good study on the effectiveness of SBIR grants in this country, but they seem to be pretty small, and whether or not that has been the right number for what we're trying to do with small businesses maybe needs to be rethought. And so that's some of the things that we're working on now. I hope that's helpful.
There are some major challenges in working with companies, big or small. One of them you get into real quickly is intellectual property issues. And sometime I think as university researchers, we get a little bit too carried away with what we have to offer. I mean, we often have some good things to offer, but sometimes it may not be all what it's about. It's also very difficult to have that type of dialogue with industry where you get real about what the issues are. Give you an example of that. If you're telling me that you're doing pre-treatment of biomass at 1 or 3% solids, I would say that's not real. If you're talking about doing pre-treatment at 20 to 40% solid, I would say, no, you're being very real. And often our industrial colleagues know that, but that wall of secrecy prevents that sharing going forward, and it makes it very difficult to do any type of real technology assessment, especially from an academic standpoint, because we tend to rely on the published literature to do that type of technology assessment.
Matt, did you have a comment? Okay, fair enough. Other question, comment?
It's a comment following whatever funding opportunities you were talking about. Since I come from the National Science Foundation, I have to put in my 2 cents now. Particularly, I want to bring your attention to SBIR was already mentioned. Chad did that, and that's one thing. And I also want to mention about the IUCRC. This is the Industry University partnership kind of a center-like program that exists in NSF for a long time. So that's something you may like to look at it. And a new initiative that started in fiscal 12, that is this year, is the ICOR, Innovation CORPS. So that is essentially addressing what Larry mentioned just now, namely how it's a pre-SBIR, like let's look at it. It's a previous stage or a preliminary stage even before you are ready for an SBIR-like project. So this essentially brings in, it's a university private sector partnership. It's a $50,000 for a year or so between a team of people, which includes, it's a NSF funded, it's a basic research result out of NSF funded research in the last 3 to 5 years, let's say, and provides an opportunity to evaluate the commercial potential of that with a mentor from the industry. And it's more based on education that is promoting entrepreneurs for future. So a grad student, a postdoc who has an idea, wants to start a small company, whether an idea has the potential for commercial viability is what's evaluated in the year with a great amount of mentorship. So that's a program that I would like to bring to your attention. It has 4, it's a quarterly open dates. for proposal submission. Very quick turnaround. Within a month or so, you get to know whether you get it or not. So about 25 per quarter is the target of awards that's being thought about. So for this first year, it's about $5 million that's available to do that. So 2 cycles of those has already happened. So 3 more cycles for this year remain. So that's another opportunity I would like you to think about. So if you have an idea for commercialization or want to evaluate the potential of its commercial viability, coming out of an NSF-funded research, that's an opportunity for you to think about.
What's the name of the program?
EPSCoR, Innovation CORPS. Yep.
Okay, great, thank you.
Maybe I'll
Next
make
question.
a comment,
Sure.
because one of the things I think as you talk, and I'm sure that as I've worked with various academic groups now and stuff, and you talk 1 to 5 million, and you kind of sit there and say, that's great. And I think working at the bench scale or small pilot facility, that's a good deal of money. You come to the beast that I showed you, and I spend $1 million a month running it. And as you're trying to get into the point of going into that demonstration stage, we're probably talking 2 to 3 months of sustained operation to say, now we're ready to move to the design phase of commercialization. So it's a different order of magnitude as you bring up. And as I've had conversations with, can you bring in different feedstocks and evaluate it for us? Well, if you really want us to evaluate it all the way through to the final fuel and produce that final fuel, you're talking about a month run. You're talking about $1 million just to operate that. Now, if you want 4 or 5 days, I can give you how did the syngas composition change, but I really don't learn anything about the final product.
AJ Foster with Oklahoma State University. My question is related to water use. In terms of the projection for those meeting those biomass demands that was proposed, when we think of water use, and that's going to be becoming more and more of a bigger issue in terms of crop production and in terms of drought and in needs for irrigation, and in terms of bioenergy crop, in terms of production, adding an irrigation cost to that will be a deterrent for a lot of farmers in deciding to grow bioenergy crops, as well as for water use. Food crops would be more important for production in terms of allocating water use or water availability. So how does that play in part in terms of meeting that demand and in terms of the bioenergy production or biomass production platform?
First stab. Yeah, that's a really important point. As far as the supply curves that I was showing this morning, we don't include any irrigation on any of our dedicated crops. So there's no additional demand for irrigation. We also don't allow, in our modeling, we don't allow for conversion from pasture to dedicated feedstocks west of the 100th meridian. So in other words, in the more arid, we basically broad brush western half of the country, no pastures going into dedicated crops. So that's another constraint that we put on. You know, when you increase transpiration, maybe with some dedicated crops, yeah, we need to account for that. And under this, for example, this biorefinery sizing white paper, where I'm feeding feedstock supplies at different costs into their sizing models. At Argonne National Lab, Mei Wu, for example, is accounting for water impacts from potential dedicated crops. Some people here might beg to differ, but maybe this is premature to say, but me personally, you know, when I think about a landscape of vegetation, you know, I think about CRP land or something like that that might go into crop production or idle land that might go into crop production. You have vegetation on that land already. It's transpiring. Are you going to up that rate of transpiration from dedicated crops? Probably, but I don't know. You know, you have plants and then you have other plants. You know, so maybe that's a bit oversimplified. But it's something that we're aware of. It's something that we've constrained for in our analysis, and it's something that we continue to keep an eye on. Critical resource and sustainability. An excellent point. I just wanted to give the lab's perspective on that.
I know for a fact the Noble Foundation as well as Oklahoma State looking at drought-resistant crops, evaluating different types of crops that may be appropriate. Oklahoma is either cursed or blessed in terms of a testing ground because we have annual precipitation in the teens in the Panhandle to over 50 inches in the southeast in a normal year. As such, we can evaluate these different crops, especially for Oklahoma conditions, and extend that beyond Oklahoma to the other regions that have less rainfall to sustain a higher level of biomass production as in the southeast.
It's a very good question. You know, the intersection between water and energy is bigger than just biofuels. So power generation in general consumes a tremendous amount of water. There's a lot of evaporative water loss in the power sector. So looking at new ways to cool power stations, for example, is a technology to help mitigate that, which the agency is looking into and thinking about, as well as it was stated, you know, opportunities to improve the water use efficiency of some of these bioenergy crops is going to be very important as well moving forward. But it's a very good point.
60% of the fresh water usage in this country is for cooling power plants.
I believe you.
I think that was a number I was looking at last week because in a class we were doing water recycling. And again, you know, these issues like waters, putting them in the context of the total human system. You know, we tend to isolate. You know, we're going to focus on water, and yet, and sometimes we focus in on things that in the big picture are not the real issue. There are other drivers with that. We got into this with the food versus fuel issue, and we have interesting debates here in this U.S. And if you catch me on a bad day and we have that debate, I say eat less meat. Okay. I know your categories don't want to hear that, but again, it's putting things in the context of human development, okay, and what your priorities are. The other thing we tend to forget as academicians is that not everything we do falls in this nice, rational academic world that we like to have, okay? There's that policy domain, there's legislation, there's the market. And one of the issues I see time and time again, we get compared to the Europeans. They say, the Germans are doing this, the French are doing that. And then I look at people and say, have you ever noticed that all roads in France lead to Paris? Which means that all decisions are made. Okay? They're a much more central controlled country. Okay? In the US, we believe in a market system. That creates a very dynamic environment to deal with water, energy, and food issues like that. So sometimes we just kind of make the problem too simple to get a handle on it, but then there are more angles on it.
Good point. Another question, comment? Over there. Kelvin has one.
Is that the differential
Well, first of all, they're constantly shifting because the technology is evolving, okay? And technology evolves, okay? And the technology evolves in response to problems. So if energy efficiency is a problem, you do see a response, either driven by market or policy, and good science coming into the picture, good engineering coming into the picture to address that problem. So it's in a state of flux, okay? The other problem you run into is that we tend to be not very careful about how we draw those system boundaries and what we build into those costs and assessing those costs. And that's a real worry for me. I've come from New York State where the famous David Pimentel was on the faculty at Cornell, who for years have said that corn ethanol is an energy loser, okay? I've had a chance to look at his numbers over the years, and again, he has chosen to take technology that, as a self-respecting engineer, I would never consider for bioenergy production, but he's built that into his model, and he's been sloppy about how he's done his accounting within that boundary. And so I would urge caution in looking at some of these numbers about net energy. There are some groups that have done a really good job with that, some of them have done a really crummy job. But I'm counting on, okay, that through innovation, and I'm a real big believer, for us to deal with the sustainability challenges, we've got to innovate. And we've got to innovate around energy efficiency, economics, resource efficiency. So that's kind of my take on it.
Other comments from the panel?
Yeah, I guess maybe I'll just add a few thoughts. I think what Larry said was right on. You know, the challenge, of course, going forward is the rate of innovation in one technology versus the other, and how fast we can develop renewable technologies versus, let's just say, fossil technologies, such as, you know, fracking and horizontal drilling, just as an example. So that sort of race, if you will, is going to be interesting to see how it plays out. I think the price of petroleum is going to be obviously a major driver for how quickly these technologies are going to move. Right now we see a pretty high sustained price, even in what is termed a global recession, which is very interesting. I think a lot of the suppliers in the Middle East that are necessary and control marginal supply still are inclined to keep prices high for balancing a lot of the social structures in their countries. And so that provides more of an opportunity for fossil technologies as well to develop rapidly, because there is what is at least projected to be a more sustainable high price in oil due to some of these other pressures. So that's the race, I think, that we're in. And I alluded to it a little bit in my presentation as well, with the new developments in other fossil resources, even in this country. It'll be very interesting to see how those play out.
Another comment?
You're exactly right. Yeah.
Well, actually, that's one of the places that we're getting beat up on, because those of us who worked in the biofuel area for a long time have always talked about that recycling of the carbon. But there are environmental groups out there who are claiming that we're not accounting for the carbon we release through indirect land use. And that's one of the real challenges that we've had to deal with over the last 4 years. And indirect land use and carbon cycling has been a real difficult theme to get our arms around. And so that's been one of the major challenges to biofuels over the last 3 to 4 years.
Is it possible that there are some biofuels or some processes which do not require that year-long sort of market? Can we not look towards models in which one particular crop is used at a time and another crop is used at another time, or one technology and another technology?
Certainly from crop to crop. If we have a crop that grows it, and again, it needs to be in a regional area that can get it delivered at a reasonable cost. Our technology, we're going to be looking across a number of biomass crops. The question is, can the plant be in one location and you get different crops in at different types of year? That I think is going to be the challenge, and I don't know the answer to that. I know some of the work that Idaho National Lab was doing was with the pelletizing, and there they thought they could, one of the hypotheses is they would accumulate during the growing season pellets that then had a longevity and could provide a year-round supply. That may be the approach to it. But I think it's got to take in all those factors, not just the growing season, but how far out do you have to go in order to transport the material in when perhaps your primary product is not available. It's too expensive to let these plants sit idle. The capital cost in them is too great. A thermochemical thing, our estimate is we would run year-round for probably 2 or 2+ years. Then we would come down for a normal inspection and upgrading materials. But it's certainly not anywhere close to what we do at the demonstration site where we do 30 to 60-day runs. It's a 24/7 year-round operation that from an economic point of view has to continue.
My background's in short rotation woody crops, and there might be a real synergy between woody crops and herbaceous crops.
Yeah, that's possible.
But what you just pointed out is a real design consideration. Okay, you've got this major capital investment that you can't let sit idle. How do you secure feedstock and have the appropriate technology to handle a diversity of feedstock? And so that has to be part of your design aspect, the right technology for the right situation. Okay, and we sometimes forget that. We sometimes forget about the operational aspect of this.
And you're probably talking 1,000 to 2,000 barrels a day as a minimum size plant to be able to make it economic. Is probably what we're kind of, that's the minimum size we've been looking at. Just to give you a perspective, we have a Suncor petroleum refinery just right adjacent to us. They're about 100,000 barrels a day. We're talking 1 to 2,000. So the order of magnitude of this type of operation is much smaller, especially when you're talking about biomass fed. Now, if we were talking natural gas fed, different story.
I got another question. It's regard to who are the target producers? Because if you, from a perspective, if you're looking at grain producers, traditional grain producers, or cattle producers, what type of incentive it would be provided to get these farmers? Because the market going to dictate if like corn prices, wheat prices are pretty high now. So what type of incentive would you offer to these producers to get them to want to allocate some acres into a bioenergy crop? And then for a grazing producer, his first objective is grazing. So for his bioenergy crop, like for example, switchgrass, in a year where there is drought, he's going to graze first before he thinks about selling it for energy. So what type of incentive or programs will be in place to address such issues?
I don't have the answer on the program, but I took a stab at the answer on the price. So I think January of this year in Energy Policy, we published a paper where we coupled, if you take potential demand for biomass feedstocks to meet RFS2, and then you add to that potential demand that might be needed to meet projected production for power. So if you stack those two demand levels, then the short answer is we're probably looking at about $55 a ton farm gate price to incentivize that combined level of production. And if we run the model in a demand mode rather than a price mode, it's probably too deep into the weeds, but rather than just flat $55, if you wanted to say maybe if we were to start out at $45 a dry ton and project up to about $60 a dry ton by 2022, we think that's probably the range of prices that would be needed to incentivize the level of production to meet those combined levels of demand. I think it's 350 million dry tons by 2022. I don't know if you want to pay those prices or not.
It's well above what we've assumed in at least our initial calculations.
Now that's the final marginal price. So that last ton is going to be the most expensive ton, and there are a lot of cheaper resources that come in first. So I don't know if others here have ideas on the policy side to bring that tonnage in to help. You know, in short, we're talking about paying for that a different way. And I don't know what the policy answer is.
Well, it may not be a policy issue so much as a market issue. And because we're trying to produce cheap energy on one hand. We would like to have cheap liquid fuels that go in a car, but at the same time, we're also talking about rural economic development, okay? So we want people in rural communities to make some money, so where is that trade-off on this? I remember doing some exercises with farmers up into New York when you had that original $30 per ton number in a report, and I would ask the farmers in New York, would you produce this for me for $30 per ton? And they would all break out laughing, okay? This is that human dimension of that, okay? How do you share in the benefits from a bioenergy sector? Okay, you've got this investment you have to recover at a plant, but farmers have investment in the land and equipment, and so what does that business model look like, okay, between the farmer and the conversion facility? You know, are we talking about co-ops playing a role in all of this? I asked a question earlier today about storage of biomass. Who will be the feedstock aggregator? So if I'm a conversion folks, I would like to have a long-term contract, not a 6 months one, but a long-term contract. Who's going to meet that contract? And what kind of business model for that? We tend to turn to policy, and policy is an important part of it, but we're going to have to innovate in the business models that we bring to the table to drive this industry.
I'm going to take the moderator privilege of asking the last question, if you don't mind. And that is, my colleagues and I have been discussing how can we establish an industry in Oklahoma. I maintain that we have the intellectual capacity with the institutions who are involved in this RII and elsewhere. We are able to grow the feedstocks not only on highly productive land, but what would you consider marginal or lower productive lands. How can we get the industry in Oklahoma? Phil, I'm going to ask you first.
It's a tough one. I think it has to be finding that sort of coalition of an area where you can have farmers that are interested. Probably, I guess our bias, and it maybe goes back to the policy or political, is off marginal land. Is there a way we can find crops that will do well off marginal land? Quite honestly, we don't want to get in the food for fuel debate. We'll lose that one. We want to be able to find ways to sustain that biomass feed from either sustainable forests or from marginal land where we can improve the sustainable crops. And I think, you know, we've done some of the work, talked to a few of you about some of the, well, chromatin Chad mentioned, and We've had some discussions with them, and I'm very impressed with the genetic work they're doing to increase the production on what we might consider marginal land of sorghum, energy sorghum. If we can find that, we can put together then the feedstock supply. We can find where do the fuels go for the feedstock offtake. Then we look at that return, and I think it's going to take everybody's efforts, and I suspect it's going to take some government support, especially for the first of a kind plant. And you know, are states willing to step up and say, we will do a loan guarantee or something like this to get this plant in our location?
Are there any success stories in New York?
Believe me, it's much more challenging in New York to pull this off than it is in Oklahoma. We've invested in trying to build the bioeconomy to New York. Case in point, New York State funded 2 major pilot plants on cellulosic conversion to ethanol. The governor put $25 million on the table. This is 2 governors back. It's the same governor that gave us the $10 million to build the biofuels research laboratory at Cornell. So we look at it as part of an economic development strategy for Central New York. Most people, when they think of New York, they think of New York City, okay? And half of the state population is down by the city. The other half of the population lives in rural New York. And we've got a tremendous land base there that we have a difficult time in convincing people that we can bring to bear on bioenergy. Like Oklahoma, we have major institutions that can generate a lot of intellectual property, but how do you capture that realistically? Not just saying that it's great intellectual property. So are there ways to form incubators, research and development centers where corporation, universities, and government, state government can come together and foster development? These are some of the things that we begin to think about. I wish I could tell you that we have a real clear answer on it, but we do have an uphill battle in my part of the country convincing the feds that we can play in the bioenergy space.
With that, I guess I call this session completed. I really appreciate the response from all the panelists. Great job. Let's give them a hand.